Okay, so now we're ready to discuss the fundamental theorem of line integrals. Since it's an analog of the fundamental theorem of calculus, let's remember how the FTC goes. So here I'm going to abbreviate the fundamental theorem of calculus as the FTC from Calc 1. So the FTC says that if you have a continuous function little g of x and on some interval from a to b, and capital G is an antiderivative for little g, meaning that the derivative of capital G gives you little g back, then the definite integral of little g on the interval from a to b can be calculated by plugging in the two endpoints b and a into the antiderivative and subtracting them like this. Okay, so this is how the fundamental theorem of calculus applies, so that we can calculate definite integrals in Calc 1. Okay, so now how is the fundamental theorem of line integral similar? Well, we can think of the gradient as a kind of derivative for a two-variable function, and so a conservative vector field is for a conservative vector field, we can think of the potential function as kind of an antiderivative for the vector field f, right? Because going back to here, the derivative of capital G gives you little g, so the derivative of the potential function gives you capital F, right? So here, the potential function is playing the role of the antiderivative. So you have to be careful, right? Because here the capitalization is reversed in this case. Okay, so in any case, so now we can talk about the fundamental theorem of line integrals for conservative vector fields, right? So if your vector field is a continuous vector field and C is some piecewise smooth curve in the plane, then we can calculate the line. Again, your vector field has to be a conservative vector field, right? So the line integral over the curve C of the conservative vector field can be evaluated using just the potential function at the endpoints of the curve, right? So these coordinates x1, y1 and x2, y2 represents the initial point of the curve and the terminal point of the curve. So very similar to the fundamental theorem of calculus, where you evaluate the antiderivative at the two endpoints. For the fundamental theorem of line integrals, we evaluate the potential function at the two endpoints. Okay, so that's the basic idea of the fundamental theorem of line integrals. And so one thing to notice is that again, when you have a conservative vector field, this calculation here only depends on the endpoints of the curve C. So if you take two different curves, say C1 and C2, that have the same starting point and the same endpoint, then again, because of this calculation here, the two line integrals have the same value. And so what that means is that line integrals for conservative vector fields are independent of path, right? So to give you an illustration, right, so say x1, y1 is located here, x2, y2 is located somewhere there, right? So say you have some path C1 that goes from the starting point to the end point, and say I have another path C2 that also starts from the same starting point and ends up at the same ending point. Then again, even though these are two different paths, because they start from the same point and they end at the same point, as long as you have a conservative vector field, the calculation of the two line integrals should give you exactly the same value. Okay, so that's the basic idea. And so next we'll take a look at how to calculate an example.